2.1 just focuses quickly on the real number system and how to categorize any given number into the correct sets, including rationals, irrationals, naturals, wholes, and integers. And then the second part is just focusing on how to put them in order from least to greatest. So it's a very short section. The key is that you understand these terms that we went over on the Cornell sheet, and maybe you might need to use this chart to help you categorize these. But the key is that you eventually memorize these so that you can do this without looking here. Okay? So it says name the set or sets of numbers to which each real number belongs. Now each of these are sets. Okay, each of them represents a set of numbers. So 5 is a whole number. All right, and it is also a positive number. So remember, maybe the first thing to do is determine if it's rational or irrational. So it's always going to be one or the other. So one of these is always going to be the answer. So why don't we go through all of these and decide if it's crazy decimal or not a crazy decimal. So 5 is a solid number. There's no decimal at all, which means it's not crazy. So that's going to be a rational, but remember, we can't use R for rational, we use Q. Okay? So negative 8 over 2, is that crazy or not crazy? Well, that's really equivalent to negative 4, which isn't a decimal at all, so that's not crazy. So we'll call that Q. Remember, rational is Q, irrational is I. Not crazy, irrational is crazy. Now when we take the square root of 25, that comes out, 26. It comes out to be 5.0990, and it keeps going. So that is a crazy decimal, so we're going to call that an irrational. However, when you take the square root of 36, actually we're going to change this, the square root of 36 over 7. Okay. When you do that, you end up getting the square root of 36, which is 6 over 7. And that is a quotient. It's a division. So automatically it fits into the rationals because remember Q, a rational, is anything that can be written A over B as a quotient. So this is going to be a Q for rational. So that's the first thing I would suggest is go through and determine if it's crazy or not crazy. This is not crazy. This is crazy. Once you've done that, now if it's irrational, it's not going to fit into any others because remember, that irrational box right here is completely separate from all the others. So if it's irrational, it's going to be nothing else. If it's rational, it could fall into multiple other categories or just one or maybe none. So you have to look at it closer. So this guy's done. If it's irrational, done. Okay. Number 1 is a whole number. It's a positive number. Okay. So this is one of those numbers that when you're a small child you naturally would see because it's a small positive number. So it does fit into the naturals. And since the naturals represents this innermost circle, then it actually fits in all the rest of them too. So naturals, wholes, and integers, which remember is Z. All right, so if it fits into the inside box, then it fits into all of those boxes up through the blue integers. All right, negative 4. That is not a natural number because naturally as a child you don't learn negatives first, okay? That is going to fit here into integer because it's a negative number. Wholes and naturals are only positives and zeros. So we know it's an integer Z. And that's it. Q and Z. Okay. Finally, 4 is 6 over 7. Now, these numbers, remember inside the circle, are all whole numbers. So if it's not a whole number, 6 over 7, it's not going to fit into this category here, which means it can't be an integer, a whole, or a natural, which means all it's going to fit into is right here, the rational numbers, writing a fraction as A over B. So that's all we got for that one. Okay, So the key to doing this, first determine if it's rational or irrational, because every single one will have either a Q or an I. And then beyond that, it's a matter of memorizing either this chart or these terms and their definitions. So whatever works for you, you've got to know those so that you can clearly and correctly identify each of these. The second part is probably not as challenging. We want to put them in order from least to greatest, and the easiest way to compare any numbers is in decimals. So what we'll do first is change them all to decimals first, and then compare them. So when you're changing them to decimals, you want to think like money. So $5.24. You want to think along the lines of at least 2 decimal places to compare them, and sometimes you might have to go out even further. So for example, the square root of 5, don't just write 2.2, write 2.23. This guy is of course 2.36, and then if we do 7/3, we type in 7 divided by 3, that gives us 2.33. So the smallest one, now think money, comparing money, $2.23, $2.36, $2.33. So the smallest one's going to be $2.23, so that's radical 5. Then the 33 cents, so 7/3, and then the 36 cents. Now when you put them in order from least to greatest, you can't use their decimals. You have to go back to the originals. So make sure you use the originals, and make sure you go least to greatest. I get students sometimes that flip them around, go greatest to least. 9 is tricky because they're all negatives. And remember, if you think about the number line, the negatives go actually in the they go in the opposite order than the positive. What did I do? There we go. There we go. The negatives go in the opposite order than the positives. So you have to kind of remember that when you're dealing with this. So first let's figure out what the decimals are. Radical 12. Ignore the negative sign because we can just take the square root of 12 and we get 3.46, and then just put the negative sign on the front of it. Okay. And then this is 3.48, and the square root of 11, negative radical 11. Just again, take the square root of 11, which is 3.32, and then put the negative on the front. You don't need to put the negative into the calculator. All right, now, if we had these and we're putting them in order and they weren't negative, then $3.32 would be the smallest. But since we're dealing with negatives, we actually will do the largest one, the one that appears to be the largest, first, because we're going from left to right and the negatives are flip-flopped. So one that appears to be the largest, if you ignore the negative sign, would be $3.48. So that's actually the smallest. Then $3.46, then $3.32. So if they're all negative, you need to remember that the order is going to be flip-flopped from the actual value, like the absolute value of those things, if you ignore the negative sign altogether. Okay. Finally, number 10, same deal. We need to find the decimal here. So now take the square root of 6 and push equals, and then divide it by 5 and push equals, and you get 0.48. And then 3 divided by 7 is 0.43, but we have a problem. If we put 0.43, then we won't know how it compares to this one. So it actually, if we go out one more decimal, it'd be 0.428. And then we can clearly see that that is smaller than 0.43. So this is just cents, there's no dollars here. And they're positive, so they're going to go in the order that they appear. So smallest to largest means the 0.428, or the 3/7 comes first, and then the 0.43 repeating, and then the radical 6/5. So put them in terms of money. Sometimes you have to go further than 2 decimal places if two of them match if you only use two. And then if they're negatives, they're going to go in the opposite order that you would think.